Okay, hi everyone, welcome back to this live stream for Windows Server 2003. So I just want to share my screen. Okay, creating and managing interfaces. The network interfaces node in the RRAS snap-in shown in figure 9.5 shows you a summary of the routable interfaces available on your machine for all protocols. It lists all of the LAN and demand dial interfaces plus two special interfaces maintained by RRAS, loopback and internal. Each of the interfaces displayed has a type, a status, either enabled or disabled, and the connection status associated with it. For example, a Windows Server 2003 machine in the default configuration with a single NIC displays the local area connection interface. Each of those interfaces represent a potential destination for routed packets. You can right-click each interface and get a pop-up menu with some useful commands, including disable, enable, and unreachability reason, which tells you why an interface is marked as unreachable. There are some commands specific to demand dial interfaces which will be covered in the following sections. Managing interfaces. Each LAN interface has its own properties. These interfaces, which appear when you select the general node under the IP routing node in RRAS, correspond to the LAN interfaces you've defined in RRAS. You can set general properties for the interfaces. Once you add specific routing protocols to the interfaces, you can configure those protocols individually, as you'll see in a short while. To see the properties for an interface, just select the general node in the console, click the interface of interest in the right-hand pane, and select Action Properties, which brings up the Local Area Connection Properties dialog box. In the following sections, we'll look at the various configuration options that are available for LAN interfaces. The General tab. The General tab allows you to set some useful parameters for the entire interface, including whether or not this interface will send out router discovery advertisements so that other routers on your network can find it. The controls on the General tab do the following. The Enable IP Router Manager checkbox controls whether this interface allows IP routing at all. When it's checked, the administrative status of the interface will appear as up, indicating that it's available for routing traffic. When it's unchecked, the interface will be marked as down and it won't route any packets, nor will other routers be able to communicate with it. So you can see here figure 9.6, the General tab of the Local Area Connection Properties dialog box. The Enable Router Discovery Advertisements checkbox controls whether or not this router will broadcast router discovery messages. These messages allow clients to find a nearby, in network terms, router without any manual configuration on your part. When this checkbox is enabled, the controls below it become active, so you can set the following properties. How long advertisements are valid in the advertisement lifetime minutes field. Clients will ignore any advertisements they receive after its lifetime has expired. What preference level is assigned to this particular router in the level of preference field. Clients use routers with higher preferences first. If there's more than one router with equal preference levels, the client can randomly select one. The minimum and maximum time intervals for sending advertisements, RRAS will send out advertisements at a randomly chosen interval that falls between the minimum and maximum. With the default settings, that means RRAS will send out an advertisement every 7 to 10 minutes. The inbound filters and outbound filters buttons allow you to selectively accept or reject packets on the specified interface. You can accept all packets that don't trigger a filter or accept only those packets that match filter criteria. Each type of filter can use the source or destination IP address and net mask as filter criteria. For example, you can construct a filter that rejects all packets from 206.151.234.0 with a net mask of 255.255.255.0 that effectively screens out any traffic from that subnet. The Enable Fragmentation checkbox tells your router to reject any fragmented IP packets instead of accepting them for processing, because flooding a router with fragmented IP packets is a popular denial of service attack. You may want to check this box. The Configuration tab. The Configuration tab the configuration tab may seem out of place in the local area connection properties dialog box because it essentially duplicates what you see when you edit the properties of a LAN interface from the network and dial-up connections folder. You use this tab to set the IP address, subnet mask, and the default gateway for an interface if you want it to use a different set of parameters than the ones defined for the interface. The Advanced button allows you to specify multiple IP addresses on default gateways, just as the TCP IP properties dialog box does. So you can see here figure 9.7, the configuration tab of the local area connections properties dialog box. Setting up demand dial interfaces. When you install RRAS, it will automatically create an interface for each LAN connection it can find. If you want to create new demand dial interfaces, you'll have to do it yourself. Fortunately, there's an easy way to do this with the demand dial interface wizard, which you activate with the new demand dial interface command available when you right-click the network interfaces node in the RRAS console. In the following sections, we'll look at the separate steps involved in setting up demand dial interfaces. Naming the interface. The first page in the wizard in the interface names page, where you specify the name you want the new interface to have. This is the name you'll see in the RRAS console, so you should choose some name that identifies the source and destination of the connection. For example, HSV ATL for a connection between Huntsville and Atlanta. This is particularly useful when you want to use one RRAS console somewhere on a network to manage many RRAS servers. Having an easy way to see which link you're working with can be very valuable. Choosing a connection type. The connection type page of the wizard allows you to specify which type of demand dial interface you will create. Demand dial interfaces can use a physical device like a modem or an ISDN adapter or a virtual private network VPN connection. For example, you can have a demand dial connection that opens a VPN tunnel to a remote network when it sees traffic destined for that network. Depending on which option you choose here, the remaining wizard pages will differ. Assuming you choose to use a physical device on the basis for your network, select a device page of the wizard prompts you to choose a device like a modem or ISDN terminal adapter to use for this demand dial interface. If the device you want to use doesn't already exist, you'll need to add it. For that reason, you're probably better off adding and configuring modems and so on before setting up RRAS. If you specified that you want to use a VPN connection, you'll see the VPN type page where you can specify what type of VPN connection to use. You have the following three choices. The automatic radio button tells RRAS to figure out the connection type when negotiating with the remote server. This is the most flexible choice, so it's selected by default. The point-to-point tunneling protocol PPTP radio button tells RRAS that this connection will always use PPTP. Likewise, the layer 2 tunneling protocol L2TP radio button indicates that you want this connection to always use L2TP, determining who to call. The next step is the same for both VPN and physical connections, even though the wizard page is labeled differently. For VPNs, you'll see the network address range and for ordinary dial-up connections, the page is labeled phone number. In either case, you should enter the phone number or IP address, which is ever appropriate of the remote router. Setting, routing, and security options. The next page is the protocols and security page, which contains 4 configuration checkboxes. The route IP packets on this interface and the route IPX packets on this interface. Checkbox controls whether this interface will handle the specific packet types or not. By default, IP routing is enabled, but IPX routing isn't. If you want to add a user account so that the remote router running RRAS or not can dial in, check the add a user account so a remote user can dial in checkbox. Some routers can handle password authentication protocol PAP, challenge handshake authentication protocol CHAP, or Microsoft challenge handshake authentication protocol MS-CHAP authentication, but others can only handle PAP. If your remote partner falls into this latter group, make sure that send a plain text password if that is the only way to connect is checked. If the system that your RRAS server is calling isn't running RRAS, it may expect you to manually interact with it, perhaps through a terminal window. This is what the last checkbox uses scripting to complete the connection with the remote router is for. Check it and you'll get a terminal window for the modem connects so you can provide whatever commands or authenticators you need. Setting dial-in credentials. If you choose to allow remote routers to dial into the RRAS machine you're setting up, you'll have to create a user account with the appropriate permissions. The demand dial interface wizard handles the account creation process for you, assuming you fill out the dial-in credentials page, figure 9.9. Microsoft recommends that you pick a username that is evident with routers. Use the link in the case HSVMCO tells you right away that this account is used for the Huntsville Orlando link. You can use ICAO airport identifier, city names, or whatever else you like. Setting dial out credentials. If you want your router to initiate calls to another router, you'll need to tell your local RRAS installation what credentials to use when it makes an outgoing call. Although RRAS uses the information you enter in the dial-in credentials page, it makes no attempt to do anything with the credentials you provide on the dial-out credentials page. Actually, it does check the password. It does check the 2 password fields to make sure you've typed the same password into each one, but that's it. The credentials you provide here must match the credentials the remote router expects to see, or your router won't be able to authenticate itself to the remote end. So in exercise 9.2, you will continue from the previous exercise with the demand dial interface wizard. In this exercise, you'll create a simple demand dial interface This requires you to have a phone number, username and password for the remote end, as well as a demand dial capable device installed in the machine. I'll probably leave this exercise because most people probably won't have this, their requirements for this exercise. Creating or removing RIP or OSPF interfaces. After you create the physical interfaces using either demand, dial, or LAN interfaces, the next thing you have to do is to create an interface for the routing protocol you want to use. You do this by right-clicking either RIP or OSPF nodes in the RRAS console, which appear after you install the routing protocols, as shown a little later in the section Managing Routing Protocols, and choosing New Interface. That displays the new interface dialog box, which lists all the physical interfaces that are available for the selected protocol. For example, if you have two NICs in a computer and have already bound RIP to both of them, you can add OSPF to either or both, but when you try to add another RIP interface, you'll get an error message. Once you select the interface you want to use, and if RRAS can create the interface, it adds the interface to the appropriate item in the console and opens the corresponding properties dialog box. You can remove an RIP or OSPF interface by selecting it in the appropriate folder and pressing the delete key, by selecting Action Delete, or by choosing Delete from the pop-up menu. Setting RIP interface properties. RIP interfaces have their own properties, all of which are specific to the RIP. You adjust these settings by selecting the RIP node, clicking the appropriate RIP interface in the right window pane, and selecting properties from the pop-up or action menus. Now let's take a look at the various options available in RIP interfaces properties dialog box. The General tab. The General tab of the RIP interface properties dialog box lets you control the router's operational mode, which protocols it uses to send and accepts packets, and a couple of other useful things. Here's what you can do with the General tab. The operation mode drop-down list controls the router's mode by default. The manned dial interfaces will be set to auto-static update mode, while LAN interfaces will be set to periodic update mode. The outgoing packet protocol drop-down list controls what kind of RIP packets this router sends out. If your network has all RIPv2 routers, choose RIP version 2 multicast to make RRAS send out efficient RIP multicasts. If you have a version 1 or a mix of version 1 and version 2, there are selections for those two. The fourth choice, silent RIP, is useful when you want your RRAS server to listen to other routers' routes but not advertise any of its own. Typically, you'll use silent RIP when you're using RRAS to connect a small network, like a branch office that doesn't have any other routers, to a larger network. The small network doesn't have any routers to advertise because it's connected to only one remote network. Use the incoming packet protocol drop-down list to specify what kinds of RIP packets this interface will accept. You can choose to accept only RIP version 1 packets, only RIP version 2 packets, both version 1 and version 2 packets, or none at all. The default setting is to accept both version 1 and version 2 packets. The added cost for router field lets you control how much this router will increase the route cost. Normally it's best to leave this as 1 because setting it too high may increase the interface's cost so much that no one uses it. The tag for announced routes field gives you a way to supply a tag included in all RIP packets sent by this router. RRAS doesn't use RIP tags, but other routers can use them. The activate authentication checkbox and password field gives you an identification tool for use with your routers. If you turn on authentication, all incoming and outgoing RIP packets must contain the specified password. Therefore, all of this router's neighbors need to use the same password. The password is transmitted as clear text, so this option doesn't provide you with any security. So I'm going to leave it here this evening for this live stream. If you like listening, please consider like, sharing, and subscribing. Thank you.